Look at a ship for 1 second, a floating city made of steel, thousands of tons of metal, cars inside, people inside, food inside, probably one guy somewhere eating noodles while crossing the ocean, and yet it floats. Meanwhile, you throw a tiny metal spoon into water, and it sinks immediately like it owes gravity money. So what kind of nonsense is this? How does a gigantic ship float while a tiny chunk of metal doesn't? Well, surprisingly, physics is not broken. At first glance, ships should absolutely sink. Steel is denser than water. Density is basically how much stuff is packed into a certain amount of space. Imagine two boxes the same size. One is filled with feathers, the other is filled with bricks. The brick box is denser because more mass is crammed into the same volume. Water has a density of about 1 gram per cubic centimeter. Steel is roughly 8 times denser than water. So logically, if ships are made of steel, game over. But ships are not just giant solid blocks of steel. That would be a terrible business model. Ships float because they are mostly air, yes. The thing doing most of the heavy lifting is nothing. A ship is hollow. Inside is a huge amount of empty space filled with air. Cabins, storage rooms, engine rooms, hallways. All of this adds volume without adding nearly as much mass. So while steel itself is dense, the average density of the entire ship becomes lower. And that's what matters. Not the density of the material, the density of the whole object. Think of it like this: a bowling ball sinks, a giant inflatable pool unicorn floats. One is smaller and heavier for its size. The other is huge but mostly air and poor design choices. Ships work on the same principle: big volume controlled mass. This idea was figured out over 2,000 years ago by a Greek mathematician named Archimedes. Legend says he discovered it while taking a bath, which means one of the greatest scientific breakthroughs in history came from a guy sitting in a tub. Humanity is amazing. Archimedes discovered something called buoyancy. Buoyancy is the upward force a fluid exerts on an object. In simple terms, water pushes back, and according to Archimedes' principle, an object floating in water is supported by a buoyant force equal to the weight of the water it displaces. That sounds complicated, but it's actually simple. When a ship enters water, it pushes water out of the way. The heavier the ship, the more water it must displace. If the weight of displaced water equals the ship's weight, congratulations, you float. If not, you become a submarine very briefly, unintentionally. Ships are specifically designed to maximize displacement. That giant curved hull underneath? That's not just for aesthetics. It helps the ship displace huge amounts of water. The wider and deeper the hull, the more water gets pushed aside. More displaced water means more buoyant force. More buoyant force means your floating metal apartment remains above sea level. Naval engineers spend years calculating hull shapes, weight distribution, and balance. Because if you get it wrong, well, history has provided several educational examples, like sinking of the Titanic, too soon. It's been over a century. We can discuss it scientifically. Ships float only if their average density stays lower than water. But if water starts getting inside, a lot of problem. As water floods compartments, it replaces air. That means more mass, less helpful emptiness. The ship gets denser. Eventually, average density becomes greater than water, and gravity says, "Mine now." This is why modern ships have watertight compartments. If one section floods, doors seal off other sections. Basically, ships are built with emergency backup plans because the ocean is not forgiving, at all. So why don't ships sink, despite being absurdly heavy? Simple. They float because they're hollow and filled with air. Their overall density is lower than water. They displace enough water to generate buoyant force. And their shape is engineered to make all of this work. So next time you see a massive cruise ship floating peacefully on the ocean, remember, it is not defying gravity. It is just playing an extremely sophisticated game of be lighter than you look. Physics wins again, and thankfully so do ships. Most of the time. I hope you enjoyed this video, and please make sure you subscribe for more, and thanks for watching.